Question 6 is similar to question 5. What is the magnitude of the change in the momentum of the object? So we've got a mass m that's moving horizontally at speed u. So it's moving at speed u. So let's say this is the positive direction. And then it says it rebounds against a wall. And so we will call this the negative direction. Could go the other way if we wanted. So it moves towards the wall with momentum mu, and it moves away with negative mv, because the speed is v, but momentum is velocity, so it has to have the sign. Okay, so we're looking for the change in the momentum first. So the change in momentum is final minus initial. So it's negative mv minus the initial. And you could drop the plus sign if you wanted. So we end up, if we drop the plus sign like that. So if I bring out the m and put the rest into brackets, we come out with negative m v plus u, and we want the magnitude, which is the final step, so we don't need the negative sign here. So it's going to be mv plus u. They've written it u plus v, but it's d. Question 7, we're looking for the frictional force that acts as a cube is moving at constant velocity down a surface. So we have a cube. I'll draw it as a 2D, and it's moving at constant velocity down a slope, and the friction is always parallel to the direction of motion. So we have like that. So the component of weight to the cube parallel to the plane. So it's B. Question 8. An aircraft is moving horizontally. A parachutist leaves the aircraft and a few seconds later opens her parachute. Which graph shows the variation of the vertical speed with time t from the parachutist from the time she leaves the aircraft until just before landing? Hopefully you'll recognise this graph. It's one that was learned for IGCSE. It is in fact A. So we have velocity versus time. So the gradient is equal to the acceleration due to gravity here. And as the velocity increases, the speed increases downwards, the air resistance increases, which reduces the value of the acceleration. At this point here, the parachute is launched, ejected, and the velocity drops considerably as the drag increases. And then as the velocity drops, the drag drops, and then the forces start to equalize the weight and the drag. So it's A. Question 9 is asking us to look at the force and loss in kinetic energy for a collision. So another collision momentums question. A ball with mass m moves horizontally with speed u. So we have speed u and momentum mu. Let's say that's positive. It hits a wall and rebounds in the opposite direction with speed v, which is less than u. Okay, so the reason it said it's less than u, it means that it's lost some kinetic energy. The duration of the collision is time t. What are the magnitude of the force? So force is momentum over time. And it's also asking for the loss of kinetic energy. So the change in kinetic energy, which is kinetic energy final minus kinetic energy initial. Okay, so to find the average force, first of all, we need the change in momentum. So the change in momentum is the final minus the initial, which is minus mv minus mu. We can take out the negative m. And then if we want to actually work out the force directly, it's going to be mv plus u over t. So it's going to be either A or B. Now we need to work out the loss of kinetic energy. So to work out the loss of kinetic energy, we are going to do Ke final minus Ke initial, which is mv squared over 2, half mv squared, minus mu squared over 2, half mu squared. So if we bring that out, we have m over 2 v squared minus u squared, which you will notice is not one of the answers. However, this one is, and it's super close. And the reason the u and the v have swapped places is because the v was smaller than u, if you remember. So here they've said that v is smaller than u. So in order to have a kinetic energy loss, we need to make sure the larger speed squared is taking away the smaller speed squared. And then question 10, we've got an acceleration time graph. So what we actually have is meters per second squared on the y-axis, and then we have seconds on the x-axis. So if we're trying to find the speed, that is meters per second. So even if you don't know that the speed on an acceleration time graph is the area under the line, you could work it out by looking at the units. So what you do is you say, I've got my acceleration unit, I've got my time unit. What do I do with these quantities, these symbols, in order to get meters per second? And hopefully you'll be able to notice that if you multiply the two together, we'd have meter seconds divided by seconds squared. These cancel out and you end up with meters per second. So what you do is you multiply. So if we're multiplying the y-axis by the x-axis, we are finding the area under the line. So we're looking for the speed of the object when the time is 15 seconds. So we've got to find the area under the line for this triangle and then this rectangle. So I'm going to split it into two. You could do it another way, but I'll just split it into two. So I can see that this one is a triangle. So it's base times height over 2, the area of a triangle. So base times height, I'm at 5 times 10 is 50. divided by 2 is 25 meters per second. And then for this rectangle, I've got 5 times 15 minus 10. So this bit's 5 and this bit's 5. 5 by 5 is 25. Again, meters per second. So the total speed is 25 plus 25, 50.